welcome to Gardening at 58 North. So in this video I'd like to give you guys an introduction to soil improvement and why you should improve your soil. And what I will do is I'm going to basically get these two sites here. One of them I'm just going to do some very basic amendments to it, just a quick digging over. The other one I'm going to add lots of fertiliser, compost and also mulch it as well. And I'll show you the difference between a soil that's just kind of basically planted up and one that's had all the correct amendments with compost and things like that, just to show you how much of a difference it will make. And what I'll do is I'll come back at the end of the video a few months later and you'll see the difference in the two plots with the plants that I've planted and how the growth has changed over the summer. The ones that have been amended should have grown a huge amount more than the soil where it hasn't been amended. Now I've chosen this site because I know the soil here is particularly bad, but also what I've done is I've lifted up the two slabs, so the idea is it's completely isolated from each plot by at least 3 feet. These slabs are what they are known as 3x2, so they're 3 feet long by 2 feet wide, and so around each plot it's completely isolated from the other areas, so there shouldn't be any interference from one plot to the other. Also, the soil under here is very compacted, in poor condition, so it'll give a really good result showing you the difference that you can make to the soil. The soil here tends to be quite sandy. This soil here, there's a little bit of grit in it from the surface. That's just when they would lay in the slabs, but basically it's quite a sandy loam. You can see here, it doesn't look too bad actually as it comes to like the mixture of sand and loam. So basically this soil is quite loose, it's easy to dig. But the main problem is there's no organic matter, and the deeper you go in the soil in this garden, the sandier it gets. So it starts off not too bad at the surface and gets worse further down. That's common in most garden soils. If you're in an area with clay soils, you'll probably find the deeper you go, the more clay there is. Or if you're in a sandy soil, the deeper you go, the more sand there is. But basically, the main thing you want to do to improve your soil is add more organic matter. So with the vast majority of soils, the main issue is not having enough organic matter. Now soils, they're made up of a mixture of organic materials and inorganic materials. And it's the organic materials which you can add and amend quite easily. The inorganic materials is basically what your soil type is, so whether it's got a lot of clay in it or a lot of sand or a lot of loam. It's basically just decayed stones and rocks, and as they become finer and finer they become more like dust, and that's basically what makes up soil. But mixed in with the soil there's lots of other different elements. So there's the organic content matter, so that tends to be rotted, broken down vegetation, roots and leaves and things like that, but it also includes microorganisms as well, and such as bacteria or fungi and insects and worms. So with most soils you'll tend to find they're lacking in organic matter. The main reason is because the way that we garden nowadays is we just keep cutting back material, taking stuff away from the soil in the garden. We never add anything to it. So garden soils are particularly bad for this, especially if they've been in a garden for a long time, they haven't been fed. But basically what's happening is the plant has to get all its nutrients and water from the soil. It's the most important part for the plant really when it comes to growing. Some argue it's actually more important what happens underground than what happens above the ground. And the soil is where the plant has to get all its nutrients from. So every time you cut your plant, you're taking away all the nutrients it gets that's put into that growth. So for example, if you're cutting the lawn and taking away all the lawn cuttings and throwing them away, the plant has had to make those leaves or the grass blades with the nutrients that's in the soil. So it's absorbed that nutrients, put it into its leaves. You've then removed it from the garden. That means there's less now in the soil, and every time you cut it, the plant has to then take more nutrients out of the soil, and then you're taking that away from the garden. So over the years your soil is left with almost no nutrients, your grass will grow slowly, your garden plants will grow quite badly, and that's very common in garden soils around the world. So you really have to add that nutrients back. You can't expect to keep taking nutrients out of the garden and not add back to it, because the plants will just slowly get weaker and weaker and they'll slowly diminish. So it's very important that you do add nutrients back to the garden. What would happen naturally in the wild is instead of the grass being cut back, it would either be eaten by a herbivore, which would then defecate on the ground, and then that would bring back the nutrients either to the same area or a local area. It would average over time that all the nutrients taken out of the plants by herbivores would then be deposited back in the form of manure. Also, if the plants weren't eaten by herbivores and they just landed on the ground like leaf fall in autumn and it just rots into the soil, that brings the nutrients back into the original soil, and that just starts the process over again. And so in nature the nutrients recycles perfectly, but because in the garden we always take the materials away, we've broken that nutrient cycle, and so we need to put that nutrients back into the soil, otherwise the plants are just really going to start dying. So as part of that nutrient cycle, there's the organic matter. The organic matter is basically the rotting vegetation, and that doesn't just add more feed to the garden. One of the most important parts of that is actually the soil structure. So without it, what tends to happen is the particles in the soil, they tend to compact quite severely, and then when you get compaction, it's harder for the roots to grow. But one of the bigger important aspects is the inorganic materials in the soil. So the stones, the rocks, the silt and clay, they can't hold on to a huge amount of water or a huge amount of minerals and nutrients, with the exception of clay, which can hold on to minerals and nutrients and water quite well. But clay tends to hold on to so well that it still becomes inaccessible for the plants. So if you have no organic matter in the soil, the soil is compact, it can't hold much moisture, and it can't hold much nutrients, so the plant's trying to grow in there, can't get the water it needs, it can't get the feed it needs from the nutrients, and so the plants will be really weak. If you add in lots of organic matter, make sure it's well mixed within the soil. What that will mean is that the soil doesn't stick together as tightly, it doesn't compact, it keeps it a little bit looser. That allows more air into the soil, so the roots can actually breathe easier and grow better, because plants roots also need oxygen as well. It also means that the soil is looser, so the roots can grow more easily. And one of the best things about organic matter is it acts very much like a sponge, so it soaks up a lot of the nutrients, a lot of the water. So when it rains, instead of all draining out, it just acts like a sponge and it holds it all ready for when the plant needs to use it. So whenever there's a drought or a drier period, the plant still has plenty of water in the soil because it holds it like a sponge. And it also holds all the nutrients as well, stops them getting washed out by the rain. And as the organic matter slowly decays and breaks down into smaller particles, it also releases nutrients nice and slowly into the soil. So the final aspect as well of adding organic matter is you're actually adding more life to the soil, so it feeds the worms and all the other microorganisms that feed in the soil and live in the soil. If you have a dead soil, which this one here pretty much is, there's no worms, there's very few microorganisms, and you really need those microorganisms because what they do is they burrow through the soil, they create lots of little holes and tunnels that allows water and air to get into the soil more easily, also create more space for the roots to grow because there's more empty spaces that the roots can push through. They also mix the soil quite nicely, so what happens is if you have a layer of compost on top, or a layer of decaying vegetation such as a mulch, then the worms and the other organisms will help mix it through the soil, make sure it's distributed nicely throughout the whole soil, and then the roots can get better access to it. Whereas if there was no microorganisms, the soil was slowly compact, it wouldn't be kept loose over time, and you wouldn't have that mixing effect, making sure that the minerals and nutrients and organic matter is evenly spread throughout the soil. So as I say, the soil here is quite bad. What I'll be doing is I'll be adding that organic matter in the form of manure. I'm going to be using farmyard manure. It's probably horse manure. It's from the shop, so it doesn't say specifically, but horse manure is particularly good. What that will do is it'll add a lot of feed. There's a lot of nutrients in animal manures, as it's basically just a concentrated form of decomposted material. So that will add a lot of nutrients for the plants to grow well. There's also, in manure, there's a lot of partly decayed material. That partly decayed material is ideal for all the microorganisms. So that will boost the microorganisms and the fertility of the soil by increasing the nutrients. I'm also going to add a lot of compost. The compost is going to be the decomposted organic matter. The compost doesn't have a huge amount of nutrients in itself, and there's not a lot for the organisms to eat in it. There is a little bit of nutrients and a little bit of food for the organisms in the soil and for the plants, but the main idea with the compost is it's the organic matter that acts like a sponge. It'll soak up the water, it'll keep the soil nice and loose and really help the plants. I'm also going to be adding a slow release fertiliser as well. A slow release fertiliser is going to act a little bit like the manure, and it's going to add a lot more nutrients. It's also going to feed the organisms in the soil, but it's in a much more concentrated form. So the form I'm using is blood, fish and bone, which is an organic fertilizer which is slow release, so it should last the whole season. You can also get vegan varieties if you don't want an animal derived variety. They tend to be less intense, so you need a little bit more of them, but they should do a pretty similar job. They're going to be a bit more like the manures. in that there's less nutrients, but you'll need a lot more of them. So the blood, fish and bone will give the plants all the nutrients they need for the whole season long. It'll give them the main nutrients they need, which is nitrogen, potassium and phosphorus. And it particularly gives the nitrogen strong at the beginning, so it gives a really good burst of leaf growth early on. And then as the nitrogen gets used up in the soil, the potassium and phosphorus becomes more available with blood, fish and bone, just the way it's formulated, and it should give better flowering later on in the season. So you can use anything for feeds. You can even use chemical feeds. I prefer to use organic feeds because when you use organic feeds, the microorganisms can actually feed on them, and that just helps with the soil microbiome, and that will help further improve the structure of the soil by feeding the microorganisms, whereas the chemical feed, it just purely feeds the plants, doesn't feed the microorganisms. So although it does do the plants a lot of good in the beginning, it does have a shorter effect and it won't improve the soil structure at all. But chemical fertilizers are really good if you want an instant feed, because they are available straight away, whereas organic feeds, they normally take a few days or a few weeks before they're really available to the plants. So I'm going to start off now. This is the first site. What I'm going to do with this one is just a very basic digging over, what a lot of people do in the garden and expect to have great results, but then are surprised when nothing really happens. So what I'm going to be doing here is just digging it over loosely, putting in the plants, and then just giving it a good watering in, maybe a little bit of weeding, but that's about all for maintenance. So for both sites, I'm also taking out any stones, any rubbish, any roots as well, to make sure there's no weeds coming out, and any kind of large stones that might inhibit root growth. This is the site I'm going to really amend the soil really nicely. So I'll be adding lots of compost, lots of organic farmyard manure. Then I'll be adding blood, fish and bone. I'm also going to add a very small amount of chemical fertilizer, just to make sure there's nutrients there straight away. Because I'm planting the same day that I'm digging this over, it'll take a couple of days for the nutrients from the organic feed to start working. Probably take more like a week. So I want the plants to get off to a really good start straight away. So I'll be adding a very small amount of Growmore, which is a chemical fertilizer, which has all the nutrients that the plants need to get going. And then I'll also be putting in a tiny bit of Epsom salts as well, because I find even though this soil probably doesn't have a magnesium deficiency, adding a little bit of Epsom salts always gives the plants a slightly darker, greener foliage, and they always seem to perk up a little bit nicer as well. And for this soil, I'm going to be digging it deeper. Last soil I just dug it about as deep as most people normally dig soils. This one I'm going to dig deeper, make sure that the organic matter gets mixed in really nicely throughout the whole soil. I might bring up a little bit of the subsoil, and normally when they say with gardening you shouldn't mix the topsoil with the subsoil. That's because the subsoil has a lot less nutrients and organic matter, and you're going to be basically mixing that in with the richer topsoil, and so you're going to be making your topsoil poorer. But if you're adding in loads of compost, loads of manure, then you're going to improve your soil so much that it doesn't matter if you're mixing some subsoil. And what you'll actually be doing is creating a deeper topsoil, because what will happen is the subsoil you bring up will get improved with all the organic matter that you're putting in and manure. That will then become more like a topsoil, and instead of having 1 foot of topsoil, you'll have more like 2 foot of topsoil. So you've got a lot more good soil for your plants to grow in. So that's the 2 plots now dug over. You will get a slight height increase in the soil for both methods. The reason for this is you're loosening the soil. It was previously very compacted, so you're going to get a slight height increase with the soil. But one of the main reasons is if you put a lot of compost in, you're obviously adding a lot more material. You're going to have an increase in soil height. So it's something you do need to think about when you're doing this. But this soil height tends to be quite temporary. It will go back to its original height in a couple of years, and in fact this will drop down by an inch or two probably just in the next few weeks as it slowly compacts and the compost starts to decompose, as well as the manure. So be prepared for a bit of a soil increase. It's not a problem as long as you're just aware of it, so you don't have like the beds overflowing or anything like that. Now you don't need to use as much compost and materials that I've used. Any amount of feed and any organic content will be good for the soil. I'm just using a huge amount because this soil is really bad, and also because I want to give you guys a really good example of, if you want the perfect soil, the best possible, how much you need to put in. And it'll just give you a really good example later on in the year when I show you the difference in growth between the two lots. So you don't need this much. Any compost is good, but I'm just going to go excessive amounts just to show you how big a difference you can get with amending your soil. I'm also going to be mulching the back plot with manure once I've finished, and then on top of that manure I'm going to put grass just to make sure it's got the best conditions possible. Mulch is really good for the soil. It stops it from drying out, keeps it slightly cooler, so it's better for the soil organisms. It holds the moisture in nicely, but also if it's an organic mulch, you can use other mulches and they still give you the other benefits of keeping the soil slightly cooler and especially holding the moisture, which is the main advantage. The other advantage you get with organic mulches is they slowly break down, the worms pull them into the soil. That just helps cycle the nutrients better and keep the soil nice and loose. And if you're doing a no dig technique, that's one technique you can do. Instead of digging over like today, just put everything on the surface and eventually the soil organisms will pull it in and you'll get nice good soil like that. But it will take a lot longer, especially if you don't have any worms to begin with. So for example, when I dug these two plots, I haven't found a single worm yet. The soil is basically dead, no organic matter, so there's nothing for the worms to feed on, and that's why there's no worms living in there at the moment. But what you'll probably find is at the end of this experiment, I'll probably have a lot of worms in the plot at the back, and I'll probably have no more worms in the front plot here than I have already, which is basically 0 worms. So I'll show you the two soils next to each other now, side to side, so you can see the difference. So the one on the right is from the amended soil, the one on the left is from just the plain ordinary soil. You can see here it's a lot darker in colour, it's quite nice and loose and crumbly. This one though, it clumps up quite easily. You can see this one, although it clumps, it breaks apart a bit more nicely. It's a lot lighter in colour. A good way of telling if your soil has got a lot of organic content or not is the darker it is, the more organic content. Of course when it dries out and when it's damp it looks quite different, but generally if it's darker then the more organic content is in your soil and the better it is. So as for plants, these are the ones I'm going to be using for the experiment, and I've chosen these plants specifically because they show really good adaptations to having better soil. So basically some plants such as alpines and plants that naturally don't grow in good conditions, they're a lot more tolerant to soil conditions and you won't get such a big result in amending the soil. But with any plant, even if it's not a plant that normally shows much difference to the soil fertility, it will really help it if you can improve the soil. But these ones are particularly so a marked difference. So I'm going to be putting one of each in each plot. So the idea is I've got these Kong F1 sunflowers. These are really big vigorous sunflowers. They're also branching, so once the first flower finishes it will keep growing and put out more flowers. I've chosen this because if you don't feed this much, it stays quite small, has small flowers. If you feed it lots, it can have up to 100 flowers in a season and grow into a giant sunflower. The plant at the front is very similar in that if you don't feed it much, it won't grow that big. If you feed it loads, it can become a giant plant. This is a shoe fly plant known as Nicandrus phyceloides. It is a bit invasive. You have it in a tropical country. Here in Scotland it does do quite well if it's in a sunny warm position, but it really needs good soil, so that would be a good example. I've also got Cosmos here. Cosmos again is an annual, such as the other plants, so it wants to go to flower. If it's stressed, it will go to flower faster and it will stay smaller, but if it's well fed, it will flower later on and it'll have a much bigger plant and you'll have more flowers overall. And Ami is a wildflower. This one won't show such a big difference, I wouldn't expect, because it doesn't need such rich soils, but this should also show a slight change as well. So in each plot I'm going to put one sunflower, one shoe fly plant, two of these Cosmos plants. I'll try and get two that are very similar because there's two in each little section, and then I'm going to put a few Ami as well. So when it does come to manure, I've just mulched this with some more manure. Make sure it's always well rotted, composted manure. You don't want fresh manure. The reason is it's going to be quite strong. It's going to be too high in nutrients and it might actually burn the roots of the plants. So try and get composted manure whenever you can. Now with this site here, I'm also going to mulch it with some grass clippings just to add an extra layer of mulch, and it will help, as I say before, bring more organic content into the soil over the season. And I'll be doing that next time I cut my lawn, so that'll probably be in a couple of weeks' time. I don't really want to do it now because the plants are quite small. if I put more mulch around them, because I've already mulched them with manure, I'll probably be completely burying the stems. So I'll do that in a few weeks time. But apart from that, I'm going to keep these two plots pretty much under the same regime. So the way I'm going to look after these plots is I'm going to give them a really good watering now. I'm also going to see if I can get some stakes for the cosmos, because they've been growing in a polytunnel their whole life. They're not used to the outside environment and the wind, so they're going to get a bit battered about. I don't want them to get snapped, so I'll be staking them. I might also stake the sunflowers if they get really tall, but otherwise all I'm going to be doing is watering them if it's any dry conditions. I'm going to give it a really good soak just now because I've just planted them, but I don't intend to water them much over the season, only if it's really dry. And I might do a little bit of weeding as well, just to make sure the weeds don't take over. But apart from that, I'll leave them, let the weather do the rest, and I'll see you at the end of the video, which should be in a few months' time when we've got some really good growth. So this is now about halfway through the experiment, and I'd like to give you guys an update on how the plants have done. And as you can see, there's been a huge amount of growth, but much more growth from one set of plants than the other. So the first set here, you can see most of the plants have grown quite well. We've had a few flowers on the cosmos, probably only about 5 or so flowers. On the Ami here, each plant probably has 3 or 4 flowers. It's looking okay. The sunflower here is looking quite stocky, but the lower leaves are starting to go yellow already. The leaves aren't massive, and also it's quite a bit lower than this bamboo cane here. Whereas if we go over to the fed and improved soil section, you can see the Ami down here. Each plant probably has about 10 flowers. The cosmos plant is much bigger, not just more flowers, because it probably has about 20 or 30 flowers. Instead of this one here, it only has about 5, but also the size of it is much larger. And also looking over at the sunflower here, it's a much bigger plant, and you can see it's well above the bamboo cane. These bamboo canes are put in about the same height, and it's already at a later stage in life. It's already got the flower head there developing, so that'll be flowering quite soon. And there's lots of side shoots as well, so it's got lots of energy to put on lots of side shoots. So you can see huge difference between the two of them. Much bigger loss of plants, and the one that's actually made the biggest difference is the soothfly. So the soothfly down here, this one seems to be really susceptible to the feed levels. You can see it's only about 1 foot tall, it's quite small, and I'll show you the stem right at the base there. The stem is actually quite small. I just put my hand next to it to give you a sense of scale, and I'll just go across now. It's kind of hard to see the other one because it has grown so big and everything else is kind of congested with it. But if I go down here, put my hand next to that there, you can see the size difference. This one is a much bigger plant, really big stocky plant, lots of extra side shoots coming out. And if I come up to the top here, it's actually just about the same height as the sunflower there, and it's covered in flowers, and the leaves are also much bigger. So you can see how much better these plants have done. Basically all the plants are bigger in all dimensions. They've also got a lot more flowers, and they're slightly further ahead in their life cycle. But even though they're further ahead in their life cycle, because there's a lot more nutrients in the soil and they're getting all the nutrition they need, they will probably continue their life cycle after these ones are finished. So I'll come back in a few months' time. By then these ones will be starting to finish and they'll be going over, and these ones will still be growing quite strong and they'll be even bigger than they are now. So the difference should increase as time goes on. What I'm also going to do is I'm going to start deadheading some of these plants. So I've already been deadheading the cosmos. I'm also going to deadhead the sunflower as well, because this variety of sunflower is multi-branching. It should put out side shoots. There's none obvious on this yet, probably because this is a bit weaker, this plant, because there's no nutrients. It's a tiny little one just starting to form down there. But you can see on this sunflower, because it's a much better fed plant, there's lots of side shoots starting to come out. It's got the energy to spare to grow extra flowers. So I'll be deadheading them as well, making them last longer. Some of the side shoots, as this one here, have already started to grow quite long. And this cosmos, I have been deadheading it already. There's been several flowers. I'll just keep deadheading that, see how long that will go for. With the soothfly plant, I'm just going to leave that. That doesn't get too badly affected by deadheading. And same with the Ami, I'll let that go over and just kind of set seed and see how that reacts. So that's all for this part of the video, and I'll see you towards the end of summer. We'll see how big the sunflowers have got and how much of these are still going compared with the ones at the back, which have had more feed. So this is another example of a plant that's been fed and one that hasn't been well fed. So what we have here is a cornflower. This one's been very well fed, and this is actually the same age as this cornflower here, but this cornflower has been in this pot the whole time, so it's been very restricted when it comes to feed and nutrients, because all it can get is from this small pot, and this pot already had a very low nutrient soil because it was actually using seed and cotton compost. So you can see there, a very small plant, it was only had enough energy to grow a few leaves and one flower, that's it. After that flower, it's probably not going to have enough nutrients to grow anymore. It's probably going to set seed and that's going to finish. This one, for example, though, you see it is the same age, it's at the same stage of life, it's a flowering, but this one's far bigger, and it's got loads of these side branches coming up. And although it looks like a mass of lots of little plants, if I go right down the bottom here, you'll be able to see it is actually one stem, but they're all just branching off from the one stem. So what that plant has basically done is this one realizes there's not much nutrients. It has to flower and set seed as quickly as possible, and it can't waste any nutrients on the leaves. So what it's done is it's grown enough leaves to get enough energy to flower, and then it has enough leaves and energy just to produce a few seeds from that one flower. Whereas this plant knows it's got loads of nutrients, loads of water, it can afford to grow lots of leaves, and it can also afford to grow loads of flowers. So this one will keep going for months probably. I'll probably get flowers in this the whole summer, maybe up to 100 flowers, I'm not sure. It's just the beginning of the flowering season. This is the first one that's opened. But even on these side shoots, there's even side shoots forming on the side shoots. So this will probably go on to have hundreds of flowers, with this one is only going to have one solitary flower. So that's just a good example there of the difference with good nutrition and bad nutrition. And the difference will only get more extreme as the year goes on. So because this is an annual, it wants to flower, set seed and then die. Once this one has set its seeds, it's going to die. This one, however, if I deadhead it, it will keep producing flowers the whole summer long, and this one will be absolutely huge by the end of summer, because it's only June at the moment, so this has got loads of growing to do, but this one's just about copped out because it's already ran out of all the minerals and nutrients that are in this small pot. So it's now the middle of September and it's just getting towards the end of the experiment here. But as you can still see, there's a big difference between the two plants. The AMI plants here, they haven't shown the biggest difference, and if anything, I would say the ones have gone over slightly faster in the fed section, although they were much larger plants overall. You can see, for example, although this one's still alive, it's really small, and this one is well over here. It's really tiny, whereas these are all quite large plants, even if they are going over. There was one exception. That was the AMI plant here. This was the only one I didn't go into shock from transplanting, and so this one didn't flower till quite late in the year, and so became a much larger plant. I'm not going to really consider that as part of the experiment, because kind of random as to which ones went into shock and which ones didn't. All of them went into shock apart from this one plant, and because of that it grew a lot bigger. When it comes to the cosmos here, it's still quite a small plant, thin stems. It's flowering okay, but as I say, it's quite a small plant, not a huge amount of flowers. The cosmos here, although it's exactly the same when it was planted, is much larger, absolutely covered in flowers, and it's been flowering really well all summer. It's also quite a nice thick stemmed plant, quite bushy, just generally looking quite healthy. I need to do some deadheading today, but I've left the dead heads on for the last week just to give you an idea of how many flowers it has per week. And I've been deadheading constantly all these plants. You can see all the cut marks there. Now the other plants of worth noting are the soothfly plants. They're actually starting to die out now because of the cooler temperatures. This one got blown over the other day. We've had 40-mile-an-hour winds on and off for probably about 2 or 3 weeks. It's been really quite blustery. So I've staked the sunflowers and the cosmos, but the other plants haven't been staked. So this fell over. The soothfly plant here didn't fall over. Now there's a couple of reasons why that might be. It might be because the plants here are generally bigger, so they kind of mesh together and they're holding each other up. But the other reason might be the thickness of stem. So this one, for example, is quite a thin stem plant. Its roots probably haven't spread that much, so they're still in that original kind of root ball it had in its original pot, so it's going to have a smaller root system. Whereas this one here has a much bigger stem. The roots will have travelled much further and filled more of the soil and anchored it in better, so that might be part of the reason. And then the plants I'll show you now is the sunflower. There's a really big difference in the sunflowers at the moment. This one here has already had its first bloom, and I'll show you a photo now of how that was looking. It was really nice, really big flower head. I have kept the flower head actually, it's just down here, just to give you an idea of the size of it. You can see there it's quite well formed. I cut it off before it set too many seeds though, because I would like this to keep flowering and putting on new flowers. As you can see, it's doing quite well at the moment. I need to deadhead this one. It's just coming to the end. You can tell when it's towards the end because all these flowers have opened and finished and there's nothing in the middle. Whereas if I go around to a younger flower, you'll see that in the center the flowers have not opened yet, because sunflowers are actually made up of hundreds of small individual flowers, and there's kind of a hollow section in the middle there. So that tells me that was younger, still has time to grow. That's how you tell the age of a sunflower and when it's ready to deadhead. Same with these here, various ages. This one's a bit younger, as is more unopened than open, and this one's older, as is more opened than unopened. So with this one at the front, it's always been a smaller plant, less stocky, smaller leaves, less branched as well. It's also flowered later because of the lower nutrient levels, and the head's a lot smaller. You can see the size difference there. This head on the right here, it's not fully, it's not finished flowering yet, so it will get slightly bigger, but I suspect it will never get quite as large as this one. So there's quite a big difference in height, in size there. Also with the side shoots, they're a lot less well deformed, and I don't know if these are going to keep branching as well as this one here has done. And as you can see, the ones there, even the side branched sunflowers there are about the same size as this single flower, because usually the first flower is much bigger than the side branches. So I think I'll end that part of the experiment here. We're in September now. The cold temperatures are really going to slow down a lot of these plants, so I'm going to finish this main part of the experiment. But as you could see, the section that wasn't amended with any compost or fertilizer or mulch, plants are much smaller, didn't flower as well, and some of them flowered quite a bit later, whereas the fed section, much bigger flowers, and the plants kept going for a lot longer. What I will do now is I'm going to start feeding this with a liquid feed. I've not given either of these plots any feed apart from what was originally put in the soil, and that's lasted this the whole summer. But the signs that this is now wearing off in this patch. This has had signs of nutrient deficiency the whole time, with yellow leaves and stunted growth. But this patch is now starting to show signs of nutrient deficiency as well. Probably it's showing it worse than the sunflower, on the big sunflower, than this one. Because it got so big and these plants are so large, they need higher feed requirements now than the original plants currently require. So I'm going to start liquid feeding this, because ideally if you want your plants to get to the growth to the absolute maximum, as well as amending the soil and putting feed in at the beginning, you would also be doing a supplemental liquid feed throughout the season. So I'll start liquid feeding this. I'm going to give this a balanced feed just to keep it going nicely. I could give it a tomato feed to encourage flowering, but I feel that it's a nitrogen that's really deficient, and it's nitrogen that gets used up the fastest, especially with the kind of fertilizer I use. Nitrogen, it's one that goes first, and the potassium stays a lot longer. So I'll be using a high nitrogen feed on that. This one I won't give it any feed, and I'll come back to you right at the very end of the season, just as the frost kills things off, and we'll see how things have done with that extra feed. I'll show you the soil quickly now to show you the difference. So the original soil, it's just as bad as before. It does look a little bit better. That's because it's been raining recently, but generally it's quite a pale colour, and it's just got no organic matter at all, and it's got no life in it. You know, there's no worms or anything in here. It's very poor condition. Whereas when I show you the soil over on this side, which has had the mulch and all the organic matter added to it, you should see there is a lot more life. So I'll scrape out the first layer. So that's the mulch gone. Then under here we have the manure layer. So I'll scrape the manure layer off. You can see it's much darker. And then underneath that you can already see a lot more roots than there was in the other soil. That's now back to the original soil. You can see there's some little wood lices there. As I scrape into this, although it is a lot paler in colour, it's also got a lot more organic matter, a lot more roots. I'm not finding any worms. I think the problem this year has been we've had a very dry summer. If you normally when you add organic matter, you'll get a lot more worms coming into the soil. Also, because this is mounded, what I've been finding this year is the rain been flowing off the top of this. So deeper down the soil is quite damp, but the top layer has been staying really dry. This has been a slight hollow, so the rain's been collecting in there, so that's been getting a lot more water. So although this one should suffer more from the drought because it's mounded and the soil is always dry on the top, it's been growing just as well because the organic matter has held on to the moisture just a bit better. Whereas this one here has been getting extra rain from being in a hollow, and also the plants being smaller, it's going to absorb less water. So that's all for this part of the update, and I'll see you at the end of the season to see how the extra liquid feed helps. So it's now December, right at the end of the experiment. Unfortunately, I finished off the last section of the video in middle of September. We had a much colder October than I was expecting, and November was quite cool as well, so very little growth since the last update. I'll give you a quick recap of what's happened though. These plants continue to grow a little bit better than these ones over here. The cosmos especially, that was quite tolerant of the frost. That didn't actually die until a couple of weeks ago when we had -4. Until then it was still flowering, and it was actually covered in flowers, but you can see it's kind of died off now. It might be hard to tell from the video how much it's grown since the last section of the video, but it definitely was growing quite well. This one here was also flowering, but just a lot less, and as you can see at the end of the video now, it never got to a great size, whereas that one with the better compost did get much better. There was a slight improvement with the extra feed I gave it, but because it was at the end of the season, it didn't have the potential to grow too much because it got cold and then the frost came. So this was actually flowering quite well until the hard frost as well. You can see it was sending out some new side shoots, and I had collected all the flowers to show you how many it had produced over the year, but we had some really wet weather, and with the birds as well, you can see they've all completely rotted away and disintegrated, and the birds have actually eaten all the remaining heads. So there's no heads left to count, unfortunately, but this one had far more than this one over here. And this was trying to put out a few flower heads, but you can see they were much smaller and much weaker. So what I'd like to do now in this part of the video, because I think I've covered most aspects in the other parts of the video, is just a quick look at the soil, take out these plants, see what the root systems are like in the two types of compost, and also see what the soil's like after it's had a growing season and see how much it's improved. Also see if there's any microorganisms starting to return to the soil. So we can now look at the root systems. They came out quite easy because at the end of the season the plants are all dead. So on the right here we have the cosmos and the sufly plant in the poor soil. Next to that is the cosmos and the sufly plant in the good soil. You can see here massive difference in stem size on all the plants, but also the roots are much bigger on the enriched soil plants. So you can see in these have actually mostly kept within the original pot. The reason for this is the original pots had good compost in them, so they had lots of feed. The roots, they tried to expand out of that original pot area where the original roots were with the compost, but the soil was much poorer than that, so it didn't put much energy into exploring for more nutrients. And you can see a lot of the roots are contained in the original dark compost that you can see there. Same with this cosmos. Whereas with the enriched soil, the original compost, once all the nutrients was used up in that, the roots quickly spread into the other parts of the soil, because the whole soil was nice and rich, so there wasn't that defined line between the richer compost and the poor soil. So the roots quickly spread almost straight away, and you can see a much bigger root system, much larger roots that spread much further, especially with the sufly there. And the same can be seen here with the sunflowers as well. You can see the colour difference in the soil. This is the poor soil, this is the improved soil. It's much darker in appearance, but you can see here on the roots of this sunflower, as well as having thicker stem, the roots go much further across. There's quite a few large roots going a decent distance, whereas the ones here, there's one or two larger ones, but generally they're much more compact. Height wise about the same, but just a more compact root system. This one has roots that are spreading much further, as you can see from some of these roots here. So what I'm going to do now is have a close look at the soil and just look at the differences between them. So I won't talk too much about the soil because I've already spoken lots about it in this video, and the video is already really quite a long video. So this is the poorer soil. You should notice it's a lighter colour, should also be more compacted, and also there should be less living organisms in there. So as you can see from me digging that over, it wasn't too compact, probably because this soil is actually a sandy soil, so it doesn't compact easily anyway. But it's very poor colour, it's quite a pale coloured soil, so the organic matter is quite low. And also you can also see that so I'll quickly pan up because as I'm speaking you can see there's a blackbird actually eating worms out of the other plot, so that's already a good sign. The other plot already has worms. As you can see from this poor section that I was just digging, there wasn't a single worm. So we'll see what other sections like now, but I suspect there should be some worms, as that blackbird's already coming along and eating them. So I better get over there quick before he eats all the worms. So I'll start digging. This blackbird seems very tame, so he might jump into the video shot, but we'll see how it goes. So as you can see from that soil, it's really nice and loose, no compaction whatsoever. I did only see one worm though, but there must have been at least one or two more, because I did see a blackbird just eat that worm. So as you can see from this, soil is much better condition. It will stay in this good condition for several years. It's definitely worth improving the soil every year if you can, but even if you can just improve it for 1 year, that improvement will last for several years, and so you'll get a benefit for quite a long time. Even though there's a lot of effort to dig it over at the beginning, that improvement will last for several years. So I think that's all from this video. Hopefully you've managed to stay on to the end. It's quite a long one for me. And basically just add as much compost and organic matter as you can to the soil every time you plant something, because it will improve the soil massively and the plants will do all the better for it.